I mean, Mark Twain said about the weather, everybody talks about the weather, but nobody does anything about it. And when we were writing for this episode, that comment struck me, and I thought of Sheldon Cooper saying it's funny because it's true.
Yeah. Mm-hmm.
I can understand why agrarian societies in the past were kind of obsessed with the weather and weather prediction, but in modern urban settings, the weather is still a big topic of conversation.
Right. And if you have nothing else to talk about, then that's also a good conversation starter. I remember being in South Florida and hearing people say, "Are you ready for Hurricane Andrew?" And I was hearing little bits and pieces on the radio. I did not have a clue. And when I got in the car, the weather person was alerting everyone saying, "Hurricane Andrew is barreling down on South Florida. Everyone needs to be prepared." So I ran to the nearest grocery store. Everything on the shelves was completely gone. I walked out with evaporated milk and sardines. I have no idea what my plan was, but I felt like I was accomplished because I got something. That storm took the lives of 65 people. And at that time, it was the costliest at $26 million in damages.
Wow.
Yeah.
Wow. Yeah. When I was 14, I lived in Manila, and one night, Mount Pinatubo, which was a volcano about 91 kilometers away from Manila, it erupted. And it was the second largest terrestrial eruption of the 20th century. But the same night, Typhoon Yenya struck the Philippines, and that storm carried the ash so much farther than the explosion would have. In fact, about 300 people died from the storm mixing the ash with rain and creating kind of just that goop that it was so deep it just pulled people and buildings right in. That disaster would have been a lot more contained without the storm.
Yeah. Interesting. There are so many historical weather events, and weather really has changed history. And we want to talk about that today on The Afterword. And we have tonight with us Dr. Vladimir Jankovic of the University of Manchester and Dr. Elizabeth Smith of the University of Oklahoma. Welcome to you both.
Hi, I'm Holland Webb.
Hi, I'm Amy Boland.
And you're listening to The Afterword, a conversation about the future of words.
So both of you have personal stories that probably help direct you toward your work in weather. In just 60 seconds each, would you mind sharing the Cliff Notes version of your life and what drew you into the field?
Right. I'm probably going to disappoint you with my personal experience with how I started the interest in weather, which, of course, there are the gory stories of survival in the mountains of several years ago in an electric storm, in a terrible hailstorm with my son, which I'm actually trying to forget. But what I'm trying to remember, I think, was my earliest childhood memories of snow. And I think that if there is one atmospheric or meteorological phenomenon, it is snow that makes me interested in this. And I wonder if it has to do with something with the Christmas cards. If you remember the old Christmas cards with the beautiful villages with the blanketed with snow and with kind of a glitter on the houses. And I always thought this is a kind of the ultimate weather experience, and how we connected the baby Jesus with the Swiss village, it remains a mystery to me. But somehow that kind of imagery of a perfection and solitude and silence, and the kind of that acoustic buffer that snow produces in the landscape is something that really changes sort of this mundane quality of everyday life into this sublime whiteness, peace, and almost like spirituality that I probably get from those Christmas. So that's how it effectively started. And remembering myself standing in front of the window at the middle of the night and thinking, I'm the only person witnessing this snowfall in the world. And so that's how, this intense sort of personal relationship with this element that changes the mundane, the ordinary into the sublime, I suppose. And that continues. There is a history of my snow engagement, snow chasing in Pennsylvania, and experiencing the lake effect in northern Indiana. We're all part of the story.
Oh, wow. That's beautiful. Where's your home country?
I come from Yugoslavia. I left Yugoslavia in 1990, and I moved to the U.S. For my PhD, and I studied at Notre Dame for about 5 years. And of course, for those of you who know geography and meteorology, then that whole area is well known, especially in late fall and early winter for huge snowfalls. I've never expected to actually be in the middle of a kind of a major snowfall and look through it up and see the stars. You know, how thin the blanket, the squall was very thin. You could have a heavy snowfall and starlight at the same time. Incredible stuff.
Wow, that is so cool.
For me, I just remember really liking big trucks, big machines, airplanes. I had a family friend that visited often, and we visited him often. And he would take me to see planes and things like this. He really leaned into that curiosity. And at some point when I was still really young, I saw The Wizard of Oz, I think it was, and the tornado scene just really horrified me. And I was so concerned with this and that it was going to happen to me at any moment now. And I was living in West Virginia with no basement and no cellar. And I was just so terrified that it was coming, that same friend took that fear and went out and got me little kitty books on, like weather and storms. And I never did get swept off Oz, as far as I know. And here I am. I left West Virginia for Oklahoma, where there's a much more realistic threat for tornadoes. But that is actually part of my job now. So kind of came full circle and went all the way around the other way. But that is where I got started.
I remember when I was teaching in Guatemala and was watching The Wizard of Oz with some kindergartners, I think it was. And one of the little girls turned around and said to me, "The U.S. has storms like that. It's why you moved to Guatemala." Here we were, ringed with volcanoes, but hey, it was why we moved.
Very good.
Yeah, and Elizabeth, I just love this story. And not the flying monkeys that was terrifying, but the tornado.
The tornado, yes.
Yeah, well, good for you. Good for you. I'm having to go back to those flying monkeys that still to this day terrify me. Oh goodness. Well, we are having so much fun already, Holland, about this, and I'm so grateful to have Vlad and Elizabeth here. But we need a little clarification to demystify some terms, because you all are the experts. We are not. And so we'd love to throw some terms, some phrases to you, just lightning fast. It doesn't matter who takes it. Help us understand what some of these mean. The first one is atmospheric science. What are we talking about?
Yeah, so atmospheric science, that is, a broader term that includes meteorology. And this can be any part of the science that includes the atmosphere. So climate, atmospheric chemistry, all of those sciences that have to do with the really magical things that happen within our atmosphere.
I love how our guests, Holland, are using words like sublime, magical. This is, these are true scientists, but they also have art to their language. I love this. Vlad, anything you want to add to that?
No, I think I'll probably defer to Elizabeth in matters of contemporary science. As a historian, my understanding is probably going to be very different in some cases. And I'd like to kind of clarify the term meteorology in general, which is probably counterintuitive when you think that it's a science of, it literally it means the science of meteors. And you think, really? I mean, meteorology today is the science of the weather, and it's kind of atmospheric science. What do meteors have to do with this? Now, in ancient Greek, meteors refer to anything that is suspended, elevated, and actually, now that you mention it, something that is also sublime, because sublimity has that sort of a lofty feel to it. So when Aristotle, writing his book called the Meteorologica, which is the first officially sort of named book on meteorology, he was describing the science of the suspended phenomena. For Aristotle, these were phenomena that existed between the surface of the Earth and the so-called sublunary sphere, which is a kind of high enough to kind of reach the moon. You know, the perception of space at that time was very kind of blurry. Anyway, so whatever happened in that space, which would today associate with a kind of troposphere, stratosphere, what have you, was the subject of meteorology. So including, and he would put even the shooting stars. He even called the Milky Way as a meteorological phenomenon, but he thought that Milky Way was within the sublunary sphere. So you have this very interesting sort of a combination of all kinds of things put together. And so the science that was dealing with this difficult phenomena, changeable, what some people called aleatory, something that changes very quickly. And the notion of something having a meteoric existence derives from the notion of meteors as a short-lived phenomenon in the sky, okay? It could be rain, it could be whirlwind, it could be tornado for a couple of hours, right? So these are short-lived phenomena. And so meteorology stems from that. Now, the meaning changes in the late 18th century.
I love this. This is awesome. I am thrilled that we have a definition that is anything that is suspended, sublime. I love that. Okay. Moving on to the next one. Micrometeorology. So this probably taps more closely into after that 18th century thing that you were saying, Vlad.
I'm sure that Elizabeth would probably have a more precise definition of this. My work in micrometeorology, I mean, it has to do with scales. I mean, you know, meteorologists sometimes talk about the kind of synoptic scales, which is roughly kind of the lows, the cyclones. And then what would be the one below synoptic scale, Elizabeth? Meso, right. Which is around 100 kilometers, roughly,
yep.
Scale. And then micro, I'm not sure exactly if I have any number in mind, but the history of micrometeorology is interesting because it involves all kinds of things, including forest meteorology, urban meteorology from the early 20th century, developing in Germany in particular. They were quite well known. Mountain meteorology would also be a kind of, but micro, it goes all the way down to like 10 meters in scale, kind of eddies type of things and things like that. It happened on a very small scale.
Yeah. So a good example of micrometeorology might be that little swirl of leaves that you might like to, chase, the little tornado of leaves that you might see.
Oh, that's such a great example. I you can see that in your mind as you're explaining that. That's a great example.
Right. I was expecting something like citywide event would be micro, but it's really that small. Wow.
Okay. So when I see the leaves blowing in my backyard, I can credit Elizabeth with this wonderful picture.
You've got a new word to describe what's happening.
I do. There's some micrometeorology going on in my backyard. What I really need is somebody to get those leaves for me out of my backyard. All right. Next one. How about industrial meteorology?
It's a fun one. I mean, I don't think that there is an official a term called industrial meteorology in my, but what I usually think is it's any meteorological or weather phenomena that affects the operational activities in any any industrial sector. So you think of construction industry, shipping, utilities, even retail. You can call it maybe applied meteorology. Lots of ways to actually apply meteorological knowledge to optimize economic and industrial activities.
A lot of modern, or more common terminology now, it's often used as private sector meteorology for this. Yes.
Okay.
So a lot of applied working meteorology.
So this would be when we hear about something like the storm that happened in western Kentucky a few weeks ago and destroyed a factory where people were working. That would be an example of this?
So an industrial meteorologist would be somebody that would have been working to make sure that people would have been responding for that in the factory. So that company would have had an industrial meteorologist on shift.
That's good.
There is another interesting tied to it. So the forensic meteorology in cases when you have, for example, in cases when you have large-scale building projects which are delayed because of the weather. And the question is whether who takes responsibility. So it's usually the case that the large contractors will try to find a way to claim that the delay was somehow related to the force majeure, to the act of God, which is a technical terminology used to describe the impact of the weather rather than the responsibility of the contractor and their activities. So then the forensic meteorologists come into and then look into the actual data to determine what caused the delay. And these are very large sums of money. So that is part of the thing that goes into kind of insurance. And so the contracting is the whole area in which the meteorology takes, in some industries, a very important role.
Fascinating. All right, I think you all are starting to lean into this one a little bit. Mesonet. What is that?
Mesonet is basically a network of instrumentation on, in this case, a meso scale. That's what the mesonet would be. So typically you would see instrumentation spread out over hundreds of kilometers with instruments spaced out every so many kilometers, tens of kilometers between each instrument. So here in the state of Oklahoma, where I am, we have the Oklahoma Mesonet, which is an amazing mesonet, and it's partially funded by the taxpayer, actually. And so the data is free to everyone, and you can pull it out of your pocket on your cell phone and see all the data in real time, all the time. It's really incredible.
What would they use that data for?
So you can use the data just to look at, the weather all the time. So like right now, we're about to have a big winter storm here in Oklahoma. And so right now I can pull out my phone and look and see the cold front coming into Oklahoma. But there's another really good application of it, which is agriculture. So Oklahoma has a large agricultural component to it. And of course, weather is very important to agriculture, but they also are collecting information about the soil and soil temperature, soil moisture, and all of that information is available as well. And so the agriculture industry can look at that, farmers can look at that and understand more about when to plant, when to move cattle, things like this.
Do all the states have one of these networks?
Not all states have one, but more states are getting them. So the state of New York has a mesonet. West Texas has a mesonet. Kansas has a mesonet. I believe Kentucky has a mesonet. So there are more appearing.
Okay, wonderful. All right, and our last one, Doppler radar. We hear about it all the time, but help us understand what it is.
Yeah, so Doppler radar is the thing that you see on TV all the time, right, where they show you where it's raining and where it's not. It is an instrument which sends out a pulse of radio wave, or a radio wave is what I should say. And that radio wave reflects off of hydrometeors or raindrops, whatever that may be out there, and comes back and it tells us where they are. And we use that information to tell you where it's raining and where the rain is moving. And there's a whole field of science out there studying that, and we can talk more about that if we want to, but that is what a radar is. And the home of Doppler weather radar is right here in Norman, Oklahoma.
Yeah.
How about that?
Yeah.
Very good. Well, thank you all so much. This was helpful.
Yes. Okay, let's start our conversation with why. Why should we talk about history and the weather?
So meteorology, I would say, compared to a lot of the other fields folks might think of when they think of sciences, is quite young, really as a dedicated scientific profession with focused practitioners. It's really only about 100 years old or so. And so this means that understanding the history of weather forecasting quite literally is the history of our science. And so it can be like a trail of breadcrumbs of where we've been. So now that we're in the digital age and we have, an information revolution that we're living in, we're actually able to go back to some of those breadcrumbs and fill in some gaps with our capabilities now. And we're able to tell a more complete story and provide a more complete understanding of our science, which should in theory help us get the forecast a little more right.
Thank you. That's a helpful start. And Vlad, what would you add to that?
As a historian of meteorology, one of the things that I've learned over the years was the fact that understanding weather was and it continues to be one of the more difficult scientific problems of all time, really. Unlike in astronomy, where we can forecast the eclipses and the paths of planets for conceivably another 1,000 years in the future, we're having difficulties forecasting weather beyond the week these days. And the further we look, the accuracy drops. And so it is literally amazing to think that within the 100 years that Elizabeth is mentioning, we are able to actually say what the weather is going to look like tomorrow this time. It doesn't sound anything these days because we're kind of native to weather forecasting. But if you were to tell someone in 1922, when Louis Fry Richardson made a spectacularly wrong forecast with the terrible pressure gradients in the final result, if you were to tell him that we can tell exactly the temperature and the pressure in the 24, 48 hours in advance, he would say, how do you do that? And of course, that's a lesson for, I think, everyone interested in the nature of science, to see how, by understanding the nature of atmospheric behavior, by using mathematics and the enormous amount of data put together, we are able today to say something that is seemingly inconceivable for people 100 years ago. It's a huge triumph of human ability to understand nature. I think that's what I think really distinguishes meteorology within in the realm of physical sciences. Of course, we keep medicine and other disciplines away, but this is really something really stunning in the kind of magnitude of achievement.
Mm. Amazing. So let's tap into that just a little bit more. Has there been a time when meteorologists had information that shaped history, but really were not able to communicate? And you all are kind of talking about this 100-year window here. And Elizabeth, you talked about how, we're in this information age and information's whizzing past us at lightning speed. But let's talk about a time when it wasn't either communicated well, it didn't get there, wasn't received. What was the outcome?
Yeah. So, God, I mean, I spent in quite a long time looking at these specific weather events in history from the 18th century onwards. And I think, but if we get closer to the 20th and into the 20th century, when the weather starts to make real impact on both the economy and the military and the daily life in unprecedented way, then, for example, one thing that happened in 1953, the so-called the storm of the century that took place in the UK, which killed about 2,500 people and inundated the large tracts of the coast of Great Britain and the Netherlands. The Met Office, the British Meteorological Office, issued forecasts for high waters, but the lack of public warning system was such that it led to these high casualties. So on the one hand, there was science as rudimentary as it was in the early 50s, but then the lack of ability to transfer that information to the people to whom it mattered resulted in a very in a terrible situation. So as a result of this, the UK government decided to put up the Thames barrier to prevent any future flooding as a result of the storm surge that happened in the estuary, in the Thames estuary, which is an interesting example of how a major weather event changes policy. And we see it all the time. We call it a kind of a policy triggers. Policy doesn't naturally happen as a result of kind of a deliberation of people thinking we should do this or do that, but rather it piggybacks on major weather and environmental events, usually. when the governments realize that they need to do something to prevent the damage that happened at the time. This can be seen also in terms of prevention of hurricanes. So that's one major event, but you can think of hurricane, for example, Hurricane Elena in 1985, because it had a very erratic behavior in the Gulf of Mexico, and the southern states were having difficulties. The forecasters were having difficulties to pinpoint exact landfall, and so they, to prevent the terrible sort of casualties, they issued large-scale evacuation plans. So that became the largest ever peacetime civilian evacuation in the United States as a result of being cautious to prevent damages. So that's an example of a difficulty of actually optimizing the ideal decision in the process of hurricane prevention.
Fascinating. Elizabeth, do you have anything you could add to this?
Yeah. So, kind of related to hurricanes, something that I like to kind of remind people about is the, Galveston hurricane in 1900. So that hurricane, it was what we would now call a Category 4 hurricane. And it hit Galveston in September of 1900 with no official warning at all. The people of Galveston, Texas, had no idea that it was coming. But that's not because no one knew it was coming. There were actually quite skilled forecasters in Cuba that had the ability to predict is not quite the right word, but they had developed a model that allowed them to estimate when tropical disturbances that they believed to be hurricanes would impact different parts of the Gulf. And using that, they thought that a storm would be impacting the Texas Gulf Coast. But this was shortly after the Spanish-American War, and there was not a great relationship between the U.S. and Cuba at this point, and the U.S. was still administering Cuba, and the U.S. Weather Bureau was actually in Cuba, but the head of the U.S. Weather Bureau at the time, he had banned words like tornado, cyclone, hurricane. You weren't allowed to say those at all because you didn't want to panic the population. And he had also banned the Cuban Weather Bureau office from communicating with anyone except for his office because they just weren't having a great relationship, and they had resentment toward the Cuban forecasters. And so the Cuban forecasters knew that this storm was coming, but their forecast was effectively blocked completely. Yeah. And so the storm rolls into Galveston. 10,000 people or more are killed. Galveston is destroyed because of, political unrest, essentially. And you would think that, as we were discussing, this would lead to large policy changes. And eventually policy did change, but it was not rapid. It still took a long time for policy to change at the Weather Bureau and adopt hurricane forecasting techniques. And it took even longer for tornado forecasting and warning techniques to come in after that. So, change takes time, and it's not always due to scientific information.
Fascinating. Wow. Thank you so much.
Weather is not just for official meteorologists or scientists. It's also become a hobby for a lot of people. If weather is your hobby, what does that mean? What does a hobbyist do if they say my hobby is weather?
Yeah, so I think that you can frame that question in two ways. I don't know. Like maybe I'm even a hobbyist at some point. Just at some point, I became a real weather person. I don't know, but. I think weather has been important and interesting to people probably forever. Folk tales, art, literature, they all include references to it and curiosity about it. But I think in a literal sense for modern hobby practice, we can point to something changing in the context of thunderstorms around the release of Twister. So if you track college enrollment data, you can actually see it. You can see the Twister bump in college enrollments associated with meteorology programs. And people really wanted to go out and see what they saw with Twister.
And you're talking about the movie, Elizabeth, right? The movie.
Yeah.
Okay. I just want to clarify for everyone listening.
Yes.
This is an actual, because you did mention folk tales and art. And I think
yes.
movies are a part of art. So
Yeah.
I love how this is just interwoven and that did have an impact. So this movie, Twister, there is actual data that shows a bump in enrollment.
Yes. So like the generation that was in high school and middle school at the time when Twister came out, you see then a large bump basically in enrollment data. But about the time that I enrolled in college was the end, I think, of that large bump kind of nationally. And that coincided, kind of the end of that bump coincided with the large, explosion of the accessibility of mobile data in your pocket. It went from you could have, a car phone to you could have a computer in your car if you had like the really expensive mobile plan and you had to have a big antenna to now, you can have a radar scope application in your pocket on your cell phone and you can do everything on your own. So this leads to all kinds of enthusiastic activity as far as, storms go, which is what my lane is. And there is really fun, positive engagement that comes from that. We see it in the field when I'm out there. We see it in person events. We see it online. And it can be really, really joyous, actually, for people like me to share our science with someone so excited. That's really awesome. But there is also another side of that where we see sometimes some like not so great behavior. So having all of that information in your pocket can really embolden you as well. And, we'll see some really high risk decisions of people putting themselves in situations for, a few seconds, a close up video of something. And that's really dangerous and scary. And it puts everybody else like me and others at risk too. And I find it a shame too, because really from a visual standpoint, the best shot is if you're zoomed out a little bit. You can see the whole rotating storm cloud, the wall cloud, the tornado itself, and the setting sunlight. It's so beautiful. It's really so beautiful. That's the art. That's the art of it. So yeah, I think that these are things that we see the hobbyists doing now as far as storms go. And we see a lot of discussion of those things online as well. Twitter is the whole thing. We see lots and lots and lots of it. So yeah, it's an interesting place.
Speaking of storm chasing, and I did a safer version of it when I mentioned I was snow chasing, and I think that really captures the amazing thing about weather forecasting and the Doppler radar that we discussed before. So when I would look at my mobile phone or a computer and actually see the bands of snow coming, I can kind of get a good sense what's going to happen in the next 2 or 3 hours. So I was sitting in the car, and I remember doing this and in Pittsburgh and driving up north and knowing that I'm going to get the snow no matter what. To tell, again, going back to 100 years ago, to people, I know I'm going to get snow in 2 hours, in an hour drive. They said, how would you know? And it got a seer. And of course, that's now become completely normal. And everyone assumes that this they can rely on that information. And that's stunning. But the question, I think, that Holland raised, it can be inverted to the question of how was it even possible that the weather became a subject of any profession, given that historically speaking, as Elizabeth said, everyone was interested in weather since forever, literally. When you think, any community on this planet needed to have some kind of a knowledge, intuition, and even the ability to predict the weather. So the weather lore exists from the early Greek period and was actually written down by people like Pliny and the Aratus, who produced what what we now today see as the almanacs and kind of the rules to judge the weather, as they were called in England in the 17th and 18th century. And the reason why these things worked, which is fascinating, is not because they were so-called scientifically based, but because they were embedded in the generation of oral tradition. So for people who rely on these things will say, the reason I believe in this is because they have been proven by their longevity and because they were based in the human experience. So red light, red morning, it signifies a sort of a stormy afternoon and things like that. Or the high clouds will suggest in a couple of days you will get stormy weather. So these were kind of enshrined or inscribed in a kind of memorable sayings and slogans that everyone could remember and use as a kind of a toolkit, almost as a kind of a mobile phone of the 18th century, where you can actually see these little things, ready for use, especially if you're working in the field. So everyone was a meteorologist before there was meteorology, you can say, and then the science then emerged, and then it kind of normalized these things and made them mathematical, made them physical, and made them deterministic in the way we use the knowledge today.
Wow, that is brilliant. I love both of your answers, and I appreciate how you unpacked this and kind of flipped this question on its head. As a little girl, my mom would always say, if you see the leaves turn upside down, it's going to rain, and that kind of thing. So I really, those rules to judge the weather, the almanac is fantastic. It's great. So we have had so much fun in this episode, but we need to pause. But before we do, I want to ask you both, what is an essential element we need to know in order to understand the history of weather observation and forecasting? Vlad, what's an essential element? Well,
yeah, really, that's a tough one. If I have to choose one, I think from today's point of view, it is the shift from the descriptive and non-instrumental to instrumental and quantitative weather observation. Once scientists or naturalists, however you want to call them, natural philosophers as they were called back then, decided that weather can be put in numbers by reading the barometer, thermometer, anemometer, hygrometer, what have you, all kinds of instruments as they were developing in the 19th century. This is the moment in which it was possible to make a standardized comparison between geographically distant areas and also temporally distant areas when it comes to weather information. So both temporal and spatial differences were standardized within the quantitative measurement, which allowed for developing of first of all, the charts. Now you were able to produce something called the isolines, which connect places with the same temperature, same pressure, atmospheric pressure, same relative humidity, if you will. And that gives you a synoptic, immediate view of a large geographical tract. And you can read that if you're skillful, as were the Cuban meteorologists, the Galveston officers, skillful of reading these charts and being able to say, what we see here are these isobars or isotags, the lines connecting the same the wind speed. It tells us that we are going to get that sort of a wind in a daytime in this particular place, looking at these several charts. So quantification and the instrumental measurements are the key to scientific meteorology, as to many other sciences as well.
Okay, that's great. How about you, Elizabeth?
I would say the atmosphere is a fluid, and even a soup. It flows, it mixes, it churns. Observing it, understanding it, forecasting it requires us to understand all the ingredients of that soup, how they behave in changing conditions, how they affect each other, how we as people affect that soup. It's a lot of soup. It's beautiful stuff, but it's complicated. So I would encourage everybody to take some time and go outside, watch the soup get stirred a little bit. It's pretty incredible stuff.
Oh my goodness. I can't wait to continue this conversation, Holland.
Right. In the meantime, let's thank Dr. Vladimir Jankovic and Dr. Elizabeth Smith for sharing their thoughts and experiences with us. I have learned so much in the last 40 minutes. This has been a fantastic conversation. While you wait for part 2, please go to theafterwordpodcast.com and become a subscriber. Leave us a review on Apple Podcasts or wherever you get your podcast, and tell your friends about us. And as always, remember that you are welcome at our table.